this video, we're going to talk about expanding and condensing logarithms and then begin a discussion with change of base. All right, so I want to rewrite each expression as a sum or difference of logarithms. So notice for the first example, inside the log it's multiplication. So how can I separate them into two separate logarithms? And that's with addition. So we're going to do that part first. Now, I can also expand by taking the exponential power outside the log and placing it out in the front. There's not much more that we can do here. Okay, so now let's go take a look at this other example. Now, there's two things I want to stress even before we get started with this problem. Number one, ay squared is the same thing as a squared y squared. And the square root of t, that's the same thing as t taken to the 1/2 power. So notice inside this particular log, we have exponents, we do have multiplication and division. Okay? All right, so let's expand out. And now, because it's dividing by two things, I'm going to put all in parentheses. Okay, two things before moving forward. First of all, log base c of c to the 4th. Well, we know that is simplified. That's a logarithmic property we talked about earlier. That simplifies to 4. And here I'm going to distribute the negative. So now the last step, I'm going to take the exponential powers inside the log and place them on the outside. We're done here. Okay, one other interesting problem I want to take a look at then is, given that log base a of 2 is equal to c, I want to be able to determine the following. I want to determine what log base a of 8 is, and I want to determine what log base a of the square root of 2 is. Okay? Well, first of all, I want to be able to, I'm going to rewrite this over here. Now, right now, I don't have anywhere where it says log base a of 2. That's going to be the important piece of information. Can I change this problem so I can see a log base a of 2 and plug in? Well, what do you know about 8? 8 is written as 2 cubed. So I can rewrite it as log base a of 2 cubed. Now, again, the 3 I can place on the outside. And now I have a log base a of 2. Thanks to the given problem, that is c. So my answer in this case is going to be 3c. Now, I should be able to do something similar for part B. So again, I'll rewrite log base a of square root of 2. Now, thanks to the previous problem, we know that that's going to be log base a of 2 taken to the 1/2 power. Thanks to the previous example, we know that I can take the 1/2 to the outside. And again, what do you notice? I have log base a of 2. Well, thanks to the given, I know that is going to be c. So we know in this case that log base a of the square root of 2 is equal to 1/2 c. Okay, so now I want to talk about condensing logs, meaning writing it as one log. So let's start with the first example. Now again, from the previous exercises, we did the exponent powers last. So if I'm going in the opposite direction, I'm going to take care of the exponents first. So I'm going to rewrite this first as this. Now remember, the bases have to be the same in order for me to combine them. Well, because it's addition in between, I know I can condense it with multiplication inside the log. And we're done here. Okay, let's take a look at the middle example then. So again, I'm going to take care of the exponent part first. Now that the exponent is inside the natural log, okay, now can I do my multiplication and division? So I'll write it as such. Now, the only other thing that they may do is they may multiply x minus 1 times x plus 1. Easy. Product of a sum and a difference. And we're done here. All right, so now let's take a look at the very last example here. Okay. So again, I'm going to take care of the exponents. Now, when I rewrite this, I will assume the exponential powers inside the logs are going to be positive. So I'm going to write it as like this. Now, notice I have two subtractions. I could do a fraction divided by another fraction, but I would rather write it as one fraction. So what can I do? I can take out the negative from the second and the third terms, or factor it out. Okay, so let's do that. By us doing this, I now have one subtraction, meaning that I will only have one fraction for this. So again, very easy to write from here. And you really don't need the parentheses around v to the 3/4 power, but I did place them here. So now I've rewritten that as one log. Okay, the last thing I want to do in this video is to talk about change of base. Now, let me remind you about a to the x equal to m. I can rewrite that as a logarithmic equation as log base a of m is equal to x. So what I would like to do then is I'm going to rewrite here a to the x is equal to m. I'm going to take log base b to both sides. Because it is a function, I am allowed to do this to both sides. Okay. Now, I can now take the x to the outside. Now, if I want to solve this equation for x, it's very simple. I divide both sides by log base b of a. So x would be this. Okay. Now, remember what x equals. Well, x equaled here log base a of m. So I'm going to replace that x with log base a of m. Okay. This is what is called my change of base formula. Okay. So I'm going to write it again underneath. Okay. So log base a of m is equal to log base b of m divided by log base b of a. Now that base b can be anything as long as it's consistent in the numerator and the denominator like it is in this formula. So the change of base formula is useful since it calculates logarithmic expressions that are not base 10 or base e. Okay. So let's take a look at an example then. So I want to calculate log base 5 of 8. Well, according to the form, I'm going to use, again, the common log for this. So in other words, my b is going to equal 10. So that's going to be the common log of 8 divided by the common log of 5. Now, if you wanted to put this into a normal calculator, you could certainly do the natural log of 8 divided by the natural log of 5, and it should give me the exact same answer when you plug that into a calculator. So that approximation then is this. So again, notice at the beginning it's base 5, and without this change of base formula, I would not be able to put it into a normal calculator. Okay, so let's take a look at one other example then. So again, I'm going to use the common log for this. And that is approximately